In this video we're going to look at two populations. This is from the NZ Grapher website. I'll put the link in the description. And what I've got here is a set of numbers. There are 60 in total, and they're randomly chosen with a little tweak. And we're going to look at the population first, and then we're going to see whether we can see a difference when we sort this population between two sets. So there's a subset A and a subset B. So when I put all of them into the system, I see here that the minimum number is 20, the maximum number is 35, the lower quartile is 25, the upper quartile is 30, therefore the interquartile range is 5, the median is 27, and the mean is 27.533. Okay, what can we tell from those numbers? Well, first thing we can see is that these numbers are all inexact numbers. There is no sort of 22.5 or 22.8. So these are counting numbers. So these are all integers, and that's by design. So this is probably a count of something. Okay. The interquartile range is represented by the box in the box and whisker graph here. We can see that it's quite symmetrical. Maybe there is a little bit of a skew to the right, meaning sort of most of them are bunched up here to the left, and then there is a sort of a tail out here to the right, but not a big one. And we can sort of see that it's kind of symmetric by the fact that the median is 27 and the mean is also 27.5 something. So if those numbers are fairly close, it's a pretty good chance that this is going to be symmetric. Okay, what happens though when I stratify this? I split it up into the sets. Okay, now we see a stark difference. So these numbers here are from set A, these numbers here are from set B. What's the inference we can tell? We can tell clearly that population B is larger than population A. Sorry, the numbers in population B are larger than the numbers in population A. The number is of sample in the sample is the same for each case. There's 30 in set A, 30 in set B. Can we say a hypothesis that B is greater than A? Yep, pretty much. How can we tell? Well, the median is much lower in each case. The maxima is lower in both cases. The minima here is lower than the minima there. So like for like, this one set A is to the left, meaning it has lower numbers than the one on the right. That's the inference we can take from that. Something really interesting is that there seems to be a kind of a blob here of 30s for some reason. Are both of these symmetric? Well, yeah, they're fairly symmetric. There's no sort of massive skew off to one side. Symmetric meaning that they're kind of evenly balanced, like a parabola. Sort of the ones to the left of the median and the ones to the right is the same distance. And it's the same for this as well. How confident are we that these are different populations? Well, fairly confident. 30 in each set is what we're really looking at. So there's 30 in one, 30 in the other. That's pretty much enough to know that there's going to be a difference. Okay, I'm going to So now I've got two separate populations, and these are chosen from using the same criteria. But what do we notice now? Well, we notice now that the number of each set is much, much greater. There's 130 in this set and 130 in this set. Are we more confident that this criteria, which is D, is greater than C than the last one? The answer is yes. The reason being is that there are a lot more samples now, so we know that our observations are stronger. If we had 2 or 3 samples and one was greater than the other, we wouldn't really have a lot of confidence. But if we've got anything more than 100, we can be pretty confident that these numbers come from different populations. And in fact, this is a sample of kiwi from the South Island, and this is kiwi from the North Island, comparing their weights when they're caught. And we can see that the South Island kiwi is larger than the North Island kiwi. We can see it quite clearly. The median is here for the North Island and it's here for the South Island. There's quite a gap. In fact, the median there is almost in line with the smallest South Island kiwi here. So we're a lot more confident that this is greater than this. And this is called an inference. And it's a really, really important concept to get your head around. An inference is not just a hypothesis. It's a sort of what can we deduce from the data that we've got? What conclusions can we reasonably make based on the data that we've collected?